Hello, Leon. It's your Zayde Mason. I'm here to read you another book today. This one is Optical Physics for Babies. This is for you. This is a ball, as we usually see. This ball is red. It's red, see? It's red because it reflects red light. This is real. This is true. And it absorbs blue and green light. Also true. This ball actually absorbs blue and green light and reflects red light. This is a clear ball. No color. See? It's not red. Colors pass right through it. See? Red, blue, green, they all go right through the ball because it's clear. All colors combine together to make white light. See? It's white. All the colors come together and they make white light. And white light contains all of the colors. So it can be split into everything. Everything combines to make white light. And white light can be split into multiple colors. Light travels in a straight line. Well, it travels in every possible pathway, but we'll get into that another time. That is, it travels in a straight line until it hits something, like a mirror, or glass, or something reflective. If it hits something reflective, it can be reflected. See? A little red light comes out, hits a mirror, and bounces off. It can also be refracted. So it goes right through, but it comes out at an angle. Why? Because the light slows down a little inside the medium. And that was a medium. When white light is refracted, it can be separated into all the colors. And this is called dispersion. See, white light's coming out and it's split out in all the colors. It's actually called chromatic aberration in real life. And that's because when it changes media, all the different colors of light go at different speeds through the medium. But it doesn't really go into that. We can talk about that someday too. If white light hits a raindrop, which does happen all the time, out comes a rainbow. Again, chromatic aberration or dispersion allows the light to go through a raindrop from the sun and come out in multiple colors. And on a sunny, rainy day, when it's both sunny and there's rain, you might see a rainbow in the sky that looks like this. See? You'll see rainbows someday, eventually, and you'll get to see what they are and why they look like this. Rainbows' colors always appear in the order of least refracted to most refracted light. And again, that has to do with how fast the color moves through a different medium. So each one of them goes at a different speed through the water and gets spread out at a different angle because it's going slightly slower than the next. And it goes from red all the way through to violet. Sometimes light is reflected 2 times inside a rainbow, and you get a double rainbow. And look, they've even got it right. See how you've got the regular rainbow and then the outer rainbow is in the opposite color order? Most people don't notice that. Yep, that's called a double rainbow. The color order in the second rainbow is reversed, and that's what we just mentioned. That's because when it reflects a second time, it gets inverted. It's not that it's going faster, but notice there's also a distance between them, and that's because there's quite a bit of an angle difference between one and the next. So we imagine rainbows look like this. See how solid that is? But they actually look like this. See how fuzzy it actually is in comparison to that? That's because it's spread out and even. It doesn't just come in discrete values. And the reason they do that is because they are made of an entire spectrum of colors. This is all the colors. Well, this is a lot of the colors. This is most of the colors. This is representative of most of the colors. Anyway, so that's fundamentals of optical physics. Now you know optical physics. And that is today's lesson. And that is optical physics for babies. And I love you very much, Leon. And I hope you enjoyed that. And I will talk to you soon with another book.